For thousands of years, boats have played an integral role in transportation, trade, and exploration. Over time, advancements in engineering led to faster, more luxurious, and more efficient vessels. In 2024, the leisure boat manufacturing market was valued at a sizable $51.54 billion US and is growing. This represents plenty of room for new innovations. Accumulation of decaying boats in the coastal zones are becoming increasingly concerning to researchers. These decaying boats contain microplastics that are harmful to the environment. To date, it is known that about 1,300 marine species have confirmed cases of ingested plastic. In addition, a 2019-2020 study found that 60% of the fish studied globally contained microplastics. The marine industry must ask itself, is there a better way to manage the life cycle of leisure boats? Enter 3D printing, also known as additive manufacturing, a revolutionary technology with the potential to transform boat manufacturing. Surprisingly, 3D printing has been around for decades, and only in the late 2010s has the technology become advanced enough for large-scale projects. Unlike the automotive industry, which benefits from large-scale production, the marine industry relies on skilled craftsmanship and intense manual labor for fabrication. As well, most small vessels last between 10 to 30 years, but when their lifespan ends, there's often no structured end-of-life management leading to environmental harm. So how could 3D printing offer a more efficient and sustainable alternative? One of the most obvious benefits is that never-before-seen designs can be made as seen in this boat built by MOI Composites that had the internal skeleton formed from modularized 3D prints. Speed is another benefit, as traditional fiberglass boat manufacturing requires complex molds which take time and expensive tooling to produce. In contrast, the University of Maine successfully 3D printed a boat in just over 70 hours, less than 3 days with their large-scale 3D printer. Environmental sustainability is also a key advantage. Recycled materials can be used to print boats, thereby reducing waste. For example, Dutch company Tanneroos uses reclaimed polypropylene reinforced with glass fiber for the hulls of their ships. Once their boats get to be of age, they can be shredded and turned into new ones at zero material cost. With the maritime industry generating vast amounts of plastic waste, this technology supports the idea of a circular maritime plastic economy. New market opportunities arise as well. The ability to recycle marine plastics could lead to business incentives for collecting ocean waste. It also enables the creation of specialized boats for niche markets, such as this 3D printed ferry made by Rowboat. Now let's look at the types of innovation at play. The marine industry has been using 3D printing for years, primarily for incremental innovations, namely for prototyping parts to reduce R&D costs. However, the real revolution lies in the radical innovation of printing entire boat hulls. The University of Maine Factory of the Future 1.0 is a massive 3D printer capable of producing a 30.48 meter long, 6.7 meter wide, and just over 3 meter tall objects. Alcir Marine, on the other hand, has an even larger printer built by CEAD that comes in at 36 meters long and 4 meters wide. This breakthrough technology represents a discontinuous leap forward in boat manufacturing, launching the industry into an entirely new S-curve. However, like any disruptive technology, 3D printing boats comes with its challenges. High capital costs are a significant barrier, as large-scale 3D printers require substantial investment, posing a challenge for traditional manufacturers with high legacy costs. Technological limitations, such as size constraints and material selection, still present obstacles. Regulatory hurdles must also be addressed, as new materials and manufacturing methods need to meet strict safety and environmental standards in certain countries. These challenges are why this technology is still in the fermentation phase of the S-curve, waiting for a dominant design to emerge that would facilitate widespread adoption. Despite these challenges, the future of 3D printed boats is full of possibilities. complete life cycle management could become a reality, allowing boats to be fully recyclable, thereby reducing waste and environmental harm. Societal benefits could also emerge as this technology matures, drastically reducing the cost of boat manufacturing and making boats more affordable for a wider range of people, which could also have significant impacts in developing countries where affordable water transportation is essential. Though still in its early stages, 3D printing has already begun to revolutionize boat manufacturing. With the potential to lower costs, reduce environmental impact, and increase accessibility, it offers a glimpse into a cleaner, more efficient, and more inclusive marine industry. So yeah, you could say that 3D printing is truly making waves in the boating industry.